2. And we had we had to find some stuff, right? Did we find h of x and, I'm sorry, h of y and g of x? Did we find those?
I think we just set it up.
Set it up? Okay. So you're going to have to tell me what we set up, because I'm sorry, I can't remember. And that was at school, so I don't have anything to refer to on the whiteboard. So what so C was the fraction of what?
Caramel.
Was that caramel?
I think it was caramel.
The board split pretty blurry too.
Oh. Is that Chris?
Yeah.
I know what I did wrong, and I'm probably going to have to stop. Well, maybe not. I think I told you this before. The problem is the board tries to the camera tries to autofocus.
Yeah.
And it autofocuses incorrectly, so I have to fire up Logitech Capture so it doesn't try to autofocus. And I think we might be okay now. Is that correct?
Yeah, that's a lot better.
Yeah.
Okay. So, C was the fraction of caramel. The next one was cookie or something like that. Was it B?
Yeah, it was B for cookie bit.
And we said 0 less than or equals, not B, but C. Not C, but B. Yes, no, guys?
Yes.
And the fraction of espresso by mass, or whatever we said. I might even spell it right. Is this correct?
Yes.
Okay. We did f of x, did we not?
We did f of b comma c.
I'm sorry. Of course.
Yeah.
What did we say?
A is 2c plus 3b.
A times the quantity, right?
I don't know if I'm saying it correctly.
Is this what we said?
It's 2c and 3b.
So I had the coefficients mixed up.
Yeah.
Yes, no?
Yeah.
With the conditions, what are they, guys? Spout them off to me.
C is between 0 and 1. B is between 0 and 1. And C plus B is between 0 and 1. And then it's 0 elsewhere.
Now, all of you have taken multivariable calculus, have you not?
Yes, I have.
Has anyone not taken multivariable? I'm not asking if you remember or not. Did you take it?
I didn't take multivariable.
So you took Calc 1 and 2?
Yeah.
Did you find the area under surfaces? I'm sorry, volume under surfaces.
Yeah, I think we did that.
I'm sorry?
Yeah.
You did that?
I think we did.
Okay. Was that a while ago?
Yeah.
Okay, that's fine. Don't worry about it. Gentlemen, let me get primed, locked and loaded and all that kind of nonsense. I am still fighting this cold, and my voice is going to give out in about 15 minutes if I don't get a cough drop in my mouth. And I think they're all upstairs stuck on it. Let me go bug my wife, okay? Hang on. She's not inside. So I have to climb all the way up the stairs. There they are. Well, at least it's not the stairs at UPRC where to climb to the third floor, you're actually climbing 4 flights of stairs. Okay. Getting there, guys, getting there. So, I'm back, guys. Can you hear me?
Yeah.
Probably could hear that whole
Yeah.
thing, I imagine. So, if we have a regular old function, we said that if you integrate f of x over x, we found the probability that x lie between 2 bounds. Yes, no?
Yeah.
And as you remember from calculus, at least you should, that's the same exact thing as finding the area under the curve. Correct?
Correct.
Mm-hmm.
Now we have 2 variables, don't we?
Mm-hmm.
So we don't have just one x. We also have a y-axis that in pretty much everything I've seen, every text I've seen, every article I've seen, the y-axis would be coming out of the board here. Okay? When dealing with probability and statistical distributions. Okay? So the y-axis is coming out of the board, x is like normal. And I'm going to try to draw it, okay? My artistic skills are quite lacking. I'll be the first to admit that. So this is the negative x-axis. This is the negative. Actually, we don't have the negative f of, what do we have, b and c?
Right.
So we have the negative c-axis here, which actually we don't have anything over there either. If the negative b-axis would go into the board. We don't have anything there either because of this, right? Right, guys?
Right. We're limited.
Everybody?
We're between bounds, yeah.
And we know that we don't have anything in the below the CB plane. Normally we call it the XY plane, but we don't have anything in the CB plane because this is a probability density function. It is a distribution of the probability mass and how it's distributed over the variables C and B. It can never be negative, okay? So we don't have anything below the plane. Everything's above the plane. Now, I'm going to attempt to draw the curve, what it would look like. And since we have a linear function, I think, yeah, since we have a linear function of C and B, it's going to look something like this. Again, your calculus teachers, I'm sure, did a far, far, far better job of explaining and drawing 3-dimensional spaces than me. So, right, it's linear. So this is kind of going to, sort of going to form. Well, it's not kind of, sort of, it definitely will form a sheet, right, guys? A triangular sheet that has the points. And what's this point right here, guys? What's the highest value f of CB
1.
can be? 1. So it's a sheet that goes all the way to f of CB equal 1. you'd normally call this the z-axis, wouldn't you?
It depends on which way it's rotated,
True. That's fair.
but it could be.
And over here, this is going to be 1, right? Because the maximum value C is going to be 1. Down here, the maximum value is B is going to be 1. So you can think of the curve, and it's not really a curve; it's a it's a surface,
A
right?
plane.
Yeah. And right now, it's a plane because again, we have a linear function here. It doesn't have to be a plane; it could have all sorts of whacked out functions, or not functions, but features. Right now, it's a plane, and again, these are straight lines, okay? So when we try to find the probability, I think I gave you a couple of bounds, or you gave me a couple of bounds. So we said, okay, what's the probability that the fraction of caramel was between this bound and that bound, and the fraction of B cookie bits was between this and this, right?
Mhm.
Well, what we would do, guys, to find that probability is these values would form a projection. Oh God, how do I draw this? In the BC plane, or in the probability density plane. So this would be the area on the surface, and that's horribly drawn, and I think it'd actually be triangular. But we need to find this area that's outlined by the values of B and C, high and low, right? That's going to project onto this surface, this flat sheet, okay? And it's going to project onto that surface. So we don't need to find the area under the curve. We need to find the volume under the surface and how it projects down to the BC plane, okay? And this is horribly drawn, and I apologize for that. But hopefully you get the basic idea, maybe. Hopefully.
Yeah, I remember doing that in Calc 3.
Yeah.
I know, at least for me in Calc 2, we did like the shell and the sphere method, which is not quite the same thing, but it's the same
No,
kind of
it's not.
concept.
It kind of is, yeah. Where you rotate a surface
Yeah.
about one of the axes, or a line on one of the axes.
Yeah, and then we did kind of that exact thing in Calc 3
Yeah.
that you
So,
just drew.
yeah, we're not finding the area under the curve to find probability now. We're finding the volume under the surface. I just wanted to point that out. That's all. How far did we get, guys? Did we find the marginals?
No, this is all we have so far.
So
Well,
we
we
said
did.
we defined A.
Yep. And then
We have to
part
do that
B.
before we do anything, right?
Yeah. And then
What was
part
number B? Find the means?
Yep, of X and Y, but it'd be B and C really.
Something like that?
Yeah. And then C is the variance. Or not the variance, the sigma.
Standard deviations.
Yeah.
Well, the reason why you're thinking variance, Brian, I think, is because you knew darn well that to find the standard deviations, we have to look at the variance, right?
Yeah, that's halfway to it.
Yeah.
And then part D is find the probability that B is between 0.5 and 0.73.
I remember right. You picked out those numbers.
Yeah. And then that C is between 0.38 and 0.66.
You guys are going to need your calculators for this, by the way, for this part.
Yeah. And then also
probability that
both are occurring.
Okay. So 0.5 less than or equal to B, less than or equal to 0.3, while 0.38 is less than or equal to C, less than or equal to 0.66. So again, this right here, I don't know if it's obvious to you guys yet, but we're going to find, after we find A, we're going to have to find the marginals, right? G of X, H of Y, right? Because to find the means of B and C, we need the marginals. We need to get rid of the other variable. Okay? Same thing applies here, right? We need to use the marginals to find the variance of the variable by itself, and then take the square root to find the standard deviation. Here, we're going to be integrating the marginal functions that we find. But here, and when we do that, we're going to find the area under the curve, because the marginal functions are all going to involve only one independent variable, B or C. When we find this, we're finding the volume under the sphere, not the sphere, the surface. Okay. What was number E? Was it covariance?
It was like new symbols that we didn't learn yet.
Sigma XY?
Yeah, and then
Or
rho
BC?
XY. Yeah.
Yes, no?
Yeah.
This is called covariance. And probably rho BC, yes, no?
Correct.
That is the correlation coefficient. These are really, really super duper fancy names for things that really aren't that complicated. But this is math and this is engineering, so we have a whole lot of terms that we use to try and confuse people, right? Nothing, really? I'm disappointed. Ready to find A, guys?
Yeah.
Gentlemen, how do we find A? Really?
We have to, it's continuous, so we have to integrate, right?
How many integrals? 1 or 2, 3, 4? What do you want to do?
2 of them, I think.
Question or an answer?
That is definitely a question.
No, there's 2, Brian. Has to be 2, right?
Okay.
Oh, I wrote BC. This is 3C, right?
Yeah.
My bad. Yeah, there's no, that picture I showed you, which was horrible, and I apologize for that, but if this was actually a term BC, it would not be a flat sheet or a triangular thing. It would not be that at all. So we have a double integral. We're going to work on the limits in a moment. Is it dB or DC? Is it dB dC or DC dB? Do you remember?
Which one do we need to find first?
Well, we have to set this equal to 1, right? So we don't have anything else to go on. We have to set this equal to 1. These are random variables. D something, D something. This has to equal to 1. So these random variables are going to integrate out. Okay. If they don't integrate out, we did something wrong. So do we integrate over B first or over C first?
It's
been a while,
hasn't it? Either way?
For this, it doesn't matter.
Okay.
Do you see why? This is a linear function. So for the inner integral, the one that we do first, the outer one, the outer variable, that's treated as a constant. Do you remember that?
Yes.
It's treated as a constant. So sometimes it matters, okay, especially lower limit wise. But here it's not going to matter one bit.
Yeah, I think there's like some cases where you like can't solve it, but if you do it the other way, you can.
I've never run into one that you can't. I'm sure they exist, but I haven't seen one. I'm going to show you a couple where we're going to do some examples that, oh my God, it makes a huge difference,
Yeah.
right? So do you want to do B first, then C, or the other way around?
B first. Alphabetical.
Now, since we're doing B first, the inner integral, which is the second integral sign, that gets the limits of B. What are the limits of B? I'll spot you the lower one. What can B go up to? Can it go up to 1? Careful.
Is it 1 or is it C?
Or is it 1 minus C, or is it 1 plus C, right?
Oh.
Well, we've partially taken one of the limits of B into account, have we not? With the lower limit of 0. So we
you
know
have to
that's
use the third function, so it'd be 1 minus C.
Where do you get that, Brian? I always had trouble with these. Did you guys, anyone in the class, have trouble with these guys? Like, do I use 1? Do I use 1 minus something? And if it's 1 minus something, how do I find out what the something is?
Well, I thought you just do C plus B equals 1, and then you just move the C over.
It's exactly what Brian said, but I'm going to explain it a little bit more and tell you why,
Okay.
if that's okay.
Yeah,
If it's not
totally.
okay, too bad. Okay. Brian said it. He nailed it. Okay. We know that 0 has to be C plus B has to be greater than or equal to 0, no matter what. And if you add those two bad boys together, they still have to sum to 1 at most. If they can be less than 1, that's fine. If they sum to 1, that means you have a espresso-less. What'd you call it, Liam? A cappuccino? No.
Frappuccino is the cold one that's blended with ice.
Okay.
It was the original drink of this whole thing was the caramel ribbon crunch Frappuccino. That's what all this was based on.
Okay. So somebody had a horrible nightmare and came up with this drink. Okay. All right.
Drink
I'm
in
pretty
quotation
sure that's how
marks.
it came about. What's that, Brian?
Drink in quotation marks.
Yes. So
Yeah, it's like
anyway.
a drink insofar as like a smoothie is a drink or something, like with a bunch of tiny solid pieces of ice, you know?
Isn't a smoothie kind of like eating a drink, kind of?
It's like it's blended ice with like other food in it, usually like fruits. So it's
Okay.
like it has like more of a consistency of like yogurt, for instance.
Oh, okay.
Smoothies are dope.
I
Yeah.
would probably
In fact, I think
really like
smoothies actually
smoothies.
contain yogurt sometimes, which is probably why they have the consistency of yogurt.
I see. That sounds like a nice little snack. I'm not sure about the caramel and the roasted stuff and all that, but that's okay. All right. Now, gentlemen, we want to get B by its lonesome, don't we? Because this value up here has nothing to do with C. Or I take that back. I'm sorry. This value up here depends on what B can go to as the upper limit. This has B and C. So how do we get B by its lonesome? Well, the algebraic thing to do is simply to subtract C out of every single term in the inequality. Do you see that?
Mhm.
Take C out, subtract C through the whole shooting match. What do you get? Negative C is less than or equal to B, less than or equal to 1 minus C. Again, do you see this?
Yes.
The only thing I did was I subtracted C out. It's still algebraically valid, sort of. What's the problem? Can B ever go down to negative C? We know that C is non-negative. So negative C is non-positive, right? It can be negative, in other words. Can B ever equal negative C? It can't.
Mm-mm.
B is capped at 0 on the bottom end. So instead of writing this, to capture all the conditions, it's 0 is less than or equal to B, less than or equal to 1 minus C. So now we have the lower limit and the upper limit of B. Gentlemen, does everybody see that?
I don't know if it's like technically algebraically allowed, but can you just like ignore the left half of the inequality because you're only interested in the upper bound? I think that's how I
Oh,
used to do it.
yeah, you can, Brian. But you still have to make sure that your lower bound is still valid, right?
Right.
When you're doing your algebraic manipulations. And if you take both of these into account, then you end up with this. So either, I don't care how you do it. This is just the mathematical algebraic engineering reason why it is what it is. Okay, if thinking about it a slightly different way works for you, knock yourself out. Now, what I do, gentlemen, is when I have a double integral, so I don't get more confused than I already am, I write what the limits are, what variables I write what variable the limits pertain to. Does that make sense?
Mm-hmm.
And again, I got some crap on my eraser again, clearly. This stuff when I
gotta get ready.
Somebody's getting ready. Whatever this crap is that's on the board is really sticky and it's really annoying. And I'm making it worse.
Yeah, I've just smeared it.
And it actually eventually takes care of it, doesn't it? Sort of. But it is really annoying. Okay. I think we can function now, right? Okay. So we have these limits, guys. What are the limits on the outer integral, gentlemen?
That you can just do from C equals 0 to C equals 1.
It's really important for everyone to understand that after the first integration, B doesn't exist anymore. B gets integrated out once we do this first integral, okay? B gets taken care of. This function that we're going to integrate with respect to C will only have constants in C involved, okay? Does everybody understand that?
Mm-hmm.
Yeah.
And once we get there, we have to use 0, and 1 because, again, C is the only variable left. So, ready to roll this bad boy? I have no idea what it's going to be. No idea what A is going to be.
Is this equal to 1 because this is the entire probability mass?
You got it.
Okay.
These limits encompass the entire surface defined by f of B comma C. Okay, so we're integrating over all values of B, all values of C, and we're finding the entire volume. By axiom, I think it's 2, axiom 2, that volume has to integrate to 1. Did I answer your question, Brian?
Yeah, because there was like a triangle example before where we split it in half.
Right.
And then that's why we used a half.
Right.
Okay.
But that's because we had to approach f of x as piecewise continuous. Here we don't have piecewise anything. It's all one continuous, nice, smooth function. When you have absolute values, you'd be in that same boat, wouldn't you, Brian? You'd have to.
You'd get a V shape.
Yeah. Ready to roll this bad boy?
Yes.
Here we go. You guys do the well, no, this is our first one. So if you're a little rusty, follow along with me. If not, knock yourself out and see what A equals, okay? All right. So we're going to integrate this thing with respect to B first. C is a constant during the first integration, guys. So C is just a number, right? It's not to be integrated. So we're going to get, and I'm going to pull the A way out front, guys. Okay. So outer integral goes along for the ride. Okay. We're going to integrate 3b plus 2c with respect to b. Okay. So the integral of 2b db equals b squared. If you want to be totally concise, it's 2b squared over 2. So the 2's are going to cancel. I hope that's obvious. This term is going to be evaluated from b equals 0 to b equals 1 minus c. Okay? And then we have the plus c to worry about, don't we? Or the plus 3c. Well, again, the 3c is a constant. Okay? So we're integrating a constant with respect to b. And the integral of a constant with respect to b is simply b evaluated from b equals 0 to b equals 1 minus c. Do you see why I like to put which variable we're messing around with in terms? Maybe you guys are smarter than me, but that's what I do. This equals a. Okay. Integral of b squared at 1 minus c. Look who's here, guys. We have a visitor. Actually, 2 visitors.
What? There's a baby.
This is Andrew. He is my grandson, my youngest grandson.
Hello,
He is
Andrew.
also known as the A-Man. Hi, Andrew. He's a bit shy. Mommy's over on my left, as you can probably guess. That's Mommy's hand, my daughter. That's my oldest daughter, Amanda.
Hello, Professor Nolan's daughter's hand.
Hello, Professor Nolan's daughter's hand. That's what they said. Would you like to speak to the class, Amanda? Andrew, would you like to speak to the class? Do you have any words of wisdom? I see. He's being shy. Do you know how to do double integrals, Andrew?
And I think the idea
I
of
bet he
engineering
does.
statistics might be a little intimidating for Andrew.
Might be a little what?
Intimidating.
Oh, I don't know. Okay. So that was a nice surprise, wasn't it? At least it was for me. Put the limit 1 minus c in for b, and I get 1 minus c quantity squared. Oh, I forgot we still have our outer integral of c going from 0 to 1. Okay. So this is 1 minus c squared minus, what happens when we put 0 in here, guys? Don't we get 0?
Yeah, it's all going to go to 0.
Yeah, so I'm just not even going to write that, okay? Then we have 3cb evaluated for b going from 1 minus c all the way down to 0. So we're going to just get 3c out of this bad boy. Okay? This whole term is integrated with respect to c. And of course, we have the a on the outside, guys. Okay? I hope it's obvious to you that we're going to have, once we expand the square, we're going to have a second order polynomial, right?
Yes.
We're going to have c squared, right? Minus 2c plus 1 plus 3c. So this is going to go to c squared plus c plus 1. Yes, no? That's going to be the integrand. Talk to me.
Oh, I messed up. No, I didn't. Yeah, you're right.
So we integrate this bad boy, and I get c cubed over 3.
Excuse me, I had a question.
Yeah.
So I noticed for your integral, you had the plus 3cb from b is equal to 0 to b is equal to 1 minus c. But where did that go when you converted it to your Nets integral? Because I thought you would get 3c minus 3c squared.
C is a constant.
Yeah.
So
But you-
this is the coefficient of B. So it's here. When we plug the limits in, we're going to get 3C times B, with B going from 1 minus C to 0.
Mhm.
Okay. This is a constant. So are you asking why it's just multiplied by B?
No, what I was asking is because when you plug in 1 minus c for b, wouldn't that then give you a result of 3c minus 3c squared?
Crap. Yes.
Yeah. he's right.
Yes. You're exactly right. 3C minus 3C squared. Yes, no? Right?
That's what I got from that one.
Who was that? Brandon?
Yep, that was me.
Very good. Good job. So we got to fix it. My bad. Brandon's good. Do you get negative 2C squared plus C plus 1 is what we're going to integrate?
Yeah, that's what I had.
I totally forgot the minus C up here when I plugged in the B value for this. That's where I screwed up. Fortunately, just so happens that it's not real hard to fix, right? So now we have the integral of negative 2C squared. That's going to be negative 2C cubed over 3. Yes, no? 0 to 1, right? Plus C squared over 2. 0 to 1. Yes, no? Plus C, 0 to 1. And I got to come over here now. So we're going to have negative 2C cubed over 3. I'm just rewriting it, guys. Nothing more. Tell me if I screw something up. Yes, no? This I'll multiply by A, of course.
That's what I have
Okay.
so far.
Plug it in. The zeros the bottom limit just goes away, guys. Okay. Because it's going to be minus 0 times everything. So it just goes away. So just plug in the top limits of 1. So it's going to be negative 2/3 plus 1/2. Yes, no? Plus 1.
Yep.
Is that what you guys get?
Yeah.
And 3/2 minus 2/3. Convert it to sixes. I get 5 out of 6.
Mm-hmm.
Is that right,
Yes.
guys?
Yes, it is.
Yep.
So it equals A times 5 out of 6. This equals 1. Therefore, A equals 6 fifths. Any questions on 2? That's creating the constant C times B. This is just a number,
Oh,
constant. You have to plug 1 minus C into B. Does that make sense?
I got it.
Three C minus 3CB. Oh, B's gone. never mind. 3C If I remember, no. Are you ready to find h of y and g of x?
Mhm.
Yes, no? Talk to me.
Yeah. Ugh.
Yes, no?
Yes.
Are there any questions on what we've done so far?
No, that looks good to me.
Okay, here we go. How do we find g of x, guys? Do you remember?
You have to integrate.
B, right?
Yeah.
G of b
What is-
equals, and it doesn't matter what you call the marginal. Just like you know what they are.
Can I?
So this equals the integral, and it's only a single integral also. So it's the integral from 0 to 1 of f of, now we know what a is, right? So it's 6/5 of, help me out what the numbers are. Is it 3b plus 2c? Or the other? No, it's 2b plus
It
3c.
is.
Yes,
It
no?
is 2C plus 3B.
Oh, I screwed that up.
Yeah, it's the other way around.
3b, right?
Correct.
Okay. Now, it says for integrating only with respect to c, the b's are constants. Okay.
No, wait, hold on. I may have.
I thought I had it right the first time, but I don't trust my memory anymore.
I have it written down both ways.
Somebody look at their notes and tell us what we did.
I had it originally as 2C plus 3B.
When I wrote it down,
What did
A
we
was
just find for A?
For A, we did 2B
2B,
plus
3C.
3C.
Okay, let's roll with that, guys. What we did before. Actually, it's not going to matter, but let's to make things consistent. Let's do what we did A with. Okay. All right. I don't think we did a lot of math on Tuesday when we introduced the problem.
No, we did not.
So, okay. So it's 3C plus 2B or 2B plus 3C if you like. So we got to integrate this guy with respect to C. So we're going to get 6/5. That goes along for the ride. Okay. We're integrating this with respect to C. So 3C dC equals 3C squared over 2. And that goes from 0 to 1. And watch what I do here. If you guys have wonderful memories and aren't going to get things confused, that's fine. Don't have to do this. I don't care. I don't trust myself. So the B is a constant. So it's nothing more than 2B C evaluator for C equals 0 to C equal 1. Okay. And 6/5 multiplies the whole shebang, right, guys?
Yes.
Talk to me.
Mm-hmm.
So what do you get? 3/2? Yes, no? Oh, my bad. What's the upper limit? What's the upper limit of C when we're integrating with a B with respect to C? What's the upper limit? It's not 1.
The 1 minus B.
Yes, it is. My bad. Sorry about that, guys. That's my fault. It can only C can only go up to 1 minus B. It can't go all the way up to 1. If it does, then we know that B is 0, right? So that's my fault. The math would not have worked out had we not done that. So now we have 3/3 of 1 minus B quantity squared from the first portion. The second portion is 2B times the quantity 1 minus B. The zeros just drop out, guys. Okay? Go ahead and multiply this out, see what you get. So I get negative B squared. Looks like the two B's can't, no, because I forgot to multiply, shoot. I forgot to multiply this part by 3/2. My bad, again. So multiply everything by 3/2. What do you get? 3/2 of B squared minus 2B squared, right? It's going to be negative 1/2 B squared. And then 3/2 of 2B is negative 3B plus 2B. And the constant term is going to be 3/2. Did anybody get this?
I did not.
I screwed
I'm
some up.
fine
didn't
there,
I?
but don't we also need to multiply in the 6/5?
Yes. Good catch, Brandon. If we do that, do you guys get this? 18/10. That's nasty. Is that what you guys get?
That's what I got.
Yeah.
I think it works out.
Yep.
So G of B equals negative. I didn't think it would be that nasty. I don't remember it being that nasty in my notes, but that's okay. That might have been another problem I was thinking about. That's what G of B is. Now, if you notice, if you remember or note, if you remember what I said, yeah, it works out. What I was doing was I was doing this in my head. Right? The area, this is just one curve, guys. This is a quadratic curve. The area under that curve, it only involves B. The area under the curve has to go to 1. Do you see that?
Mm-hmm.
Has to go to 1 if we integrate it from 0 to 1, because again, this is a function only of B. So if you do that math, you see that it does integrate to 1, because you're going to get 18/5 here. This put 1 in here, you get 6/5 here. So double it, you get 12/5. And here you get not 12/5, 12/10. And this will be 6/10. So negative 6/10 minus 12/10 plus 18/10 all goes to 1. All right. That was tough. Ready for H of C, guys?
Yeah.
H of C. Same process. Not 1 minus B. Not 1 minus C. It's 1 minus B, isn't it, guys? 6/5, 3C plus 2B. DB, right? We have to integrate the other variable out, guys. So what do we get?
Wouldn't it be 1 minus C?
Shout it out.
Shouldn't it be 1 minus C? If you're integrating over B.
Oh, yes. Good catch. That was a test to see if anyone was paying attention. Okay, you guys ready to roll?
Yep.
Same thing, only different, right? This is going to be 6/5 times the whole thing. 3C. 3C dB is simply 3CB evaluated for B equals 0 to B equals 1 minus C plus, took the 6/5 out here, so that's good. Now we have to integrate this with respect to B. Doing this, we're just going to get nothing more than B squared, right? Right, guys?
Yes.
What do we get? 3C times the quantity, 1 minus C, right? You put 0 in for B, everything goes away. And we add to this B squared, so we get 1 minus C, quantity squared. And yeah, we did that. What do we get out of this, guys? 3C minus 3C squared plus 1 minus 2C plus 2C squared. No, not 2. Simply 1C squared. Right? This part in parentheses is this. This part is that. Okay? So you should end up with what? Negative 2C squared. And then minus 5C plus 1. Okay. So those are our G of. Let me see if I can find this example in my notes. But that's how you find the marginals. Okay. I just got to make sure we got what should be, because those numbers are bugging me. Okay, that's that problem. What's that? Nope. I had it written down in here somewhere, guys. Okay, that gives us a different.
I have a question about this.
Go ahead. So do I.
So for the last step, before you gave the final answer, you have written 3C minus 3C squared plus 1 minus 2C plus C squared. But when you have when you give your answer, you have a minus 5C, but that's a positive 3C. So I was just wondering how that worked. Because wouldn't that make just a singular C?
Don't we have? Oh crap! Yes. Yes. Coefficients here. Yes. 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 So that's and it's positive C, is it not?
Yep. And then we would
So
also
that's
need
positive 3. I was thinking it was negative 3 because I saw that. Yes.
And you still need to multiply by 6/5.
And I just noticed that.
I think that gives you the same thing I got once you multiply it.
Okay. So,
Yeah, it
so it's going to be 6/5 plus 6/5 of C minus 12/5 of C squared. Yes, no?
Yeah, that's what I got.
Okay. I was looking for my. Oh, here it is. I'm trying to find this example in my notes. I think it's actually in your textbook. I want to make sure we are right. There's the famous runner problem. All right, let's keep on chugging. Something's bugging me, but right now let's pretend everything is normal and wonderful in the world. Okay. So let's find the means, guys. Find the mean of B and the mean of C. Ready to roll?
Yep.
Okay. What can I get rid of? Can I just write what G and H are up here, maybe?
Yeah, that'd be better.
Okay. What do you have for G? What do we find for G of B?
It's negative 3/5 B squared minus 6/5 of B plus 9/5.
Okay.
Mm-hmm.
What's H of
C.
H of C? We
It
just found
is
that.
negative 12/5 C squared. Yeah, you got it. Plus 6/5 of C plus 6/5.
All right. Okay. That's not sitting with me very well. Okay. So how do we find the mean, guys? How do we find the mean? To find the mean, we need to find mu sub B, right? That's the expected value of B. How do we find the expected value of anything?
Or continuous, you integrate.
You put the stuff in the parens, right? And you multiply it by the probability density function of the variable. So we have negative 3/5 of B squared minus 6/5 of B plus 9 over 5. I was going to write 9 over 2. Okay. dB. And this is only a function of B, guys. So the limits are B can go from 0 to 1. Okay. What was B? That was the amount of cookie bits, right?
Yes.
Okay. So if you multiply this out, you're going to have negative 3 over 5 B cubed minus 6/5 fifths of b squared minus 9 fifths. This is inside the integral. So we have to integrate that, okay? So you integrate b cubed, you get b to the fourth. Minus, you integrate b squared, you get b cubed over 3. So 6 fifths over 3 is what, 2 fifths, right? Minus, did I forget to multiply the 9 fifths by b? I did. This is 9 fifths of b. So you integrate this, you get 9 tenths of b squared, right? Is that what you guys got?
Yeah.
Oh, and this is plus, by the way. This is plus at the end. What do you get? This is going to be 6 tenths. Something is not right. Don't we get negative 1/10? Is my math right?
I did not get negative 1/10.
Oh, you didn't?
I did not. Shouldn't that be
Okay,
negative 3 over 20?
Oh, crud. Yes. Everything else is right, isn't it?
And then negative 2 over 5.
And then b squared becomes 9 fifths of b becomes 9 tenths of b squared because we have to divide by 2. Okay, so that gives me a little bit more faith in what I can do. I'm still not convinced it's right, but we're going to go with it. So we have 9 tenths, right, guys? That's this. Minus 2 fifths. Actually, we should go into 20, shouldn't we, guys? 18 20ths minus 8 20ths, right?
Well,
Minus
isn't it
3.
like 2 over 15?
2
you went
over
to
15.
B cubed. Or I'm sorry,
we had
6 over.
6 over 5. We got to divide by 3. That's how I got 2 over 5.
Okay.
Yeah, he just reduced it.
Yeah.
Okay. Jeez.
Does that make sense?
Yeah.
I get 7 over 20. Is that right?
That's what I got.
That's
what I got.
believable. It's better than a negative mean when it can't possibly be negative, right? Thanks for catching that, whoever did. Seven out of 20. That's the average. That's the mean value. Ready to find H of C?
Yep.
Guys, it's the same thing. It's the same thing. We're just going to take H of C. We're going to multiply it by C. That's the expected value, of course. So mu sub C is the integral of C times negative 12 over 5 C squared plus 6 fifths of C plus 6 out of 5, right? DC, is that right, guys?
Yes.
So what do you get when you, that's going to be C cubed, raise it to the fourth power, I get negative 3 fifths C to the fourth. Yeah, 3 fifths. Plus, then we're going to integrate C squared, so we get C cubed over 3. So that's 2 fifths C cubed plus 3 fifths of C squared. And this is all limit 0 to 1. Did I do anything wrong? Let me know if I screwed anything up, guys.
That's what I got so far.
I dropped a sign already. Where did I? Right here. It's negative 3/5. I get 2/5. Is that correct? Talk to me.
Yeah, 2/5.
What's mu sub B? 7 out of 20. And this is going to be 2/5 is 8 out of 20, guys. I'm not saying these are right by any means. I'm not saying they're wrong either, by the way. I'm saying they could be right. How can I say that? I mean, the mean value of B definitely falls into the values that B can be, correct?
Yeah.
Right? How about C? Is that also true?
Yeah.
It is. What about the last ingredient, espresso? That's 1 minus B minus C, right? So
Yeah.
what's the average value of espresso? Well, that has to fall within 0 to 1 as well. Well, if you do the math up there, I believe you get 5 out of 20. Is that right? For espresso, it'd be 20 minus 7 minus 8, all over 20. So they could be right. That's all I'm saying. Nothing more.
Wait, you subtract the average of B and C from
Yeah,
1?
yeah, to find the average of espresso, right?
So it'd be 5 out of 20, 1/4.
Yep. I mean, if we got a negative value, Brian, then that'd be cause for alarm, wouldn't it?
Yeah.
Okay.
8
We have just
warning.
enough time, I think, and I think I have just enough energy in my voice. We can set up to find the variance. Are you guys ready to roll for that?
Yeah, let's set it up.
Okay. Here we go. To find the variance of B, what do we have to do, in words at least? Remember?
I'm trying to find it in
Effective-
my notes. I don't remember offhand.
Well, look
There's
up here, Brian.
there's an expected value shortcut thing.
Yep. Do you see it? I have it up here for you.
Oh, okay.
Ready to roll, guys? We just have to find this, don't we? We already know what the mean is. Got to find this, right? Everyone?
Yeah.
How do we find the expected value of B squared? Well, we know what the functions are. We multiply G of B times B squared and then integrate, right?
You say again?
We take B squared and we multiply G of B by it.
Yeah.
And yeah, we're going to get some B raised to the pretty nasty powers. But it's all polynomials. So it's all doable. So you can go from 0 to 1, gentlemen. So if you multiply through by B squared, we have a B to the 4th. Integrate, you get B to the 5th. And we're going to have to, downstairs, we're going to have 25, if I'm not mistaken. Right? 5 times 5. Then we integrate B cubed. And we get 6 over 20. B raised to the 4th power. minus b cubed over 3. So that's going to be 3/5. And it's plus 3/5 of b cubed. Is that what you guys get?
I didn't get that far yet.
Looks like 25 is going to have it. Times 20. Right? I think this is right. Multiply by 2. I get 3 out of 50.
Uh,
I ended up getting 9 out of 50, but I had a question.
Uh-huh.
So you have 3/5 b cubed, but when you are integrating that, since it came from 9/5, wouldn't it either be wouldn't it be 9 over 15 or 3 over 15? Or sorry, 9. Jeez, sorry.
Yeah, 9 over 15 is 3/5, right?
mm-hmm.
That's where this number came from.
But what I was saying is that it should be maybe not.
Did I do that right?
Yep, you did that right. I was just looking at it weird.
Well, I would hate to have you look at things weird. Guys, this answer is wrong. Why is it wrong?
It's not what I got. I don't know where you messed up.
Oh,
Well,
I know
also, you
where I
have to-
messed up.
You also have to subtract the thing.
Yeah.
Yes, I did that on purpose in case anyone's keeping score. Ah, crap. And I put everything over 25. I'll put everything over 50. So it's 3 out of, if I did it right, 3 out of 50 minus 49 over 400 multiplied by 8. And I get a negative value, so something is totally jacked.
I had 9 out of 50
You did?
instead of 3 out of 50.
What did I screw up?
I don't know.
Brian, you're supposed to know these things. Okay. I'll buy your version of events, Brian, not mine.
Oh, you should have plus 15, not plus 12. 3 over 5 becomes 15 out of 25, right?
That's because I'm an idiot. Don't everybody agree, okay? So this becomes 9, yes, no?
Yes.
And then 72 minus 49 out of 400, whatever that is. 23, yes, no? LeBron James's number? That's the variance.
Yeah, 23. Well, now he's number 6 again.
He's what?
He switched back to being number 6.
I didn't know he switched in the first place.
He was 6 in Miami, and then he was 23 in Cleveland the second time, and then he went to LA and he was 23. but now he switched back to being 6, but he's still in LA.
Is that what you guys get?
Yeah.
Guys, we're out of time. We're out of time. My knees are killing me and my voice is shot. And clearly I can't do simple math. Have a wonderful weekend. I'll try and get on Discord. I'll try to get some homework problems up there for you, okay?
All right.
All right, guys? Excuse me. Have a good weekend, guys. Take care. Stay safe.
Nice weekend, Professor.
There's
That was good.
Bye-bye.